looking for volunteers to help get notes.
Disco is doing it.
Yeah, I know, but sometimes, another. Thanks. Well, we're so honored and monitored to have the two EDs in the front row that we want to have security, super high quality.
No, there will be, of course, right?
Okay, let's get started. Hello, everyone, and welcome to Stub Networks Auto Configuration Workgroup meeting. We have, let's go to, you guys are familiar with Notewell and participation policies with IETF. Please go through them if you're not familiar. Mask policy is still in effect, and I see everybody has masks in the room. That's great. And we have note takers. We have at least Esco who's helping us, and who else? And we have one more person in the participants who will be helping with the note taking. And about since last meeting, as you guys know, we have one working group document that was Lemon Stub Networks, and now it has been workgroup adopted, and we have additional co-author on the list now, but we haven't seen a lot of reviews since the document was updated last time. So we are really soliciting for people to come and review the document in all aspects, that it is covering all the areas. Are you satisfied with what's written in the document? Does it make sense to you? If you think something is missing, please flag those issues on the mailing list and post comments there. We would like to get this document in a very good shape. Especially notice that there are very minor changes since the version we had from last meeting. So please review the document. And in terms of agenda, I just updated you from the chair side. Ted is going to present remotely. He will give an update on the document, and please ask as many questions as you have from him. After that, we have another work which is related to land prefix delegation, and Tim is going to present that work. And since it's a very light agenda, we have time for discussion, any other topics that you would want to raise in the meeting. So with this, Ted, I'm going to share your slide deck.
Okay. Can you hear me?
Yes.
Great. Okay, so this is just a quick update on where we are with the SNAC simple document right now. Next slide. We posted a -0 in September, and then we got a decent number of comments on the mailing list. A lot of them were more editorial than sort of content related. And we added Jonathan as an author, so thanks, Jonathan. So we published an 01 in 2020 on March 8th. And we still have an issue open on GitHub, which is for a more substantive change, which I haven't had time to do yet, which is to add a state machine description for NAT64. We already have one for the behavior of the stub router on the infrastructure network in terms of router advertisements. So just the idea is to do something equivalent for NAT64, because right now it's pretty underspecified. Next slide. So I think what's missing in this document right now is somebody other than me to look at it. And that's not to say that I'm not going to do this too, but somebody other than me and Jonathan really to look at it and think about how they would implement it. Because this is a challenge always when you're writing a document like this, that like I know exactly what I did to implement it. And when I write the document, I think that I've written down everything that I did, but then somebody else comes along and actually tries to do the implementation and they have a lot of questions. And so it would be really great if somebody who hasn't done an implementation of this would sit down. You don't actually have to do an implementation of it, although that would be awesome if you did. But just sit down and read the document and think about like, what code would you write? You don't have to write it. And then send questions. So another thing that is sort of I wouldn't say an open issue, I think it's actually in pretty good shape, is the stub router RA flags document. We added that because we want to be able to differentiate between sort of official router advertisements on the infrastructure network and stub router advertisements. So we don't want to get into a situation where you have two stub routers connected to the infrastructure that are servicing perhaps different stub networks, and each of them advertises an RA, and each of them sees the other stub router's RA as being an infrastructure service. And so each of them says, oh gosh, there's already an infrastructure service there, I'll stop advertising mine because the infrastructure service is always going to be preferred. And if that happens, then what you'll see is that the two stub routers will fight with each other. So the idea with the RA flag is just to say, this is an advertisement for a stub router, so don't consider it to be infrastructure, and therefore, don't get into a fight with me. And there's a in the spec, it tells you how to, if you see a competing stub router advertisement, what to do. In order for that to happen, we need this document published. And this is not a document that the SNAC working group can do because it's really a 6-man document. However, we took this to 6-man in London, and they were very receptive to it, but they basically said, you guys write the document, get it into the shape that you want it in, and then bring it to us. Like, don't make us work on it in this working group because you guys are the ones that actually need this. So that's kind of one of the tasks before us. And then, there's just various things. Like I reread the document a little bit while I was preparing the slides, and I noticed that section 8, there's useful information in section 8, but it doesn't really tell you why it's there. And I think that needs some work. And I suspect that there are more things like that. So I think we need to make another pass through the document looking for stuff like that. It's always good to look at it with fresh eyes. So next slide. So just to go into a little more detail on the RA flag document, Jonathan Hui published the document. It's just draft Hui, stub router flag or something like, I don't remember the exact title. So I think we don't really need to do a whole lot more work before we actually send this to 6-man. Right now, the only complaint that I had when I reread the document before, while I was preparing slides was maybe the applicability statement should come before the description of the. That's a pretty minor nit, but I think it'd be worth fixing. And then I think it would be good to get a little clearer about when to send the stub router flag, or where to send it, I should say. Do we only use it in infrastructure, or do we also use it on the stub network? We talked about this last time, and the question was like, is it useful to use the stub flag everywhere, or just places where we're sort of joining as a stub router? So sort of advertiser would be like, we just use it whenever we send a router advertisement, and joiner would be, we only use it in context where we're joining an infrastructure network. So next slide. So basically, I think the advantage of the joiner model is it lets us tell whether there are other stub routers on the infrastructure. And if we see a stub router RA on the stub network, then that's an indication that something is misconfigured, right? Like, because if we're not sending the stub router flag when we send an RA on the stub network, but then we receive an RA that's got a stub router flag set, then that's a stub router that thinks that the stub network is its infrastructure network, which we don't support. So it could be useful just in terms of sort of, informing the end user that that's happening. We could do the same thing with the advertiser model, where we advertise the RA, the stub router flag on the stub network. But I think the idea is to detect that incorrect configuration. But I think it actually works better to do it with the joiner model. I'm actually sort of realizing that as I read the slides too, so I apologize for only noticing that. But it's obviously it was useful to put this down on the slides. So then the question is, like, do we want to say something about, like, if the stub router sees something like that, what does it do? Can it, do we want to talk about a user interface to inform the user or something like that? Or I don't think we can really do anything adaptive. That's what we try to do in HomeNet, and I think that's out of scope here. Next slide. So as I said, let's get the stub router document ready for 6-man. I've told you what I think about it. I'd appreciate it if other folks could think about what I've said and look at the documents and see what they think about it. Like, having just explained the joiner model and the advertiser model to you, I'm really leaning towards the joiner model, which actually is great because it means less work. But it would be great if other people could think about this and see what they think. And then, as I said earlier, it really would be helpful to have somebody who hasn't implemented this go through it. Jonathan and I will go through this before the next meeting and do our best to see if we can find gaps. But someone else who hasn't already done this would be really great. And then also with the state machine, we'll try to get that done before San Francisco. I apologize for not having done more work on this since London. It's been a really nutty couple months, and that just wasn't in the cards. So, but I think we'll have time to work on it for San Francisco. So next slide. If there is a next slide, I don't think there is.
No.
Yeah, so that's basically it. I should have put a Q&A slide at the end, but I didn't. So any comments would be greatly appreciated. Esco?
Ted. So I think what you were saying is that stub router would actually need to be reviewed by our working group here. Yes. And do a sort of a mini working group last call before we can move it to 6-man, right? So I think it just needs then more reviews by people.
Yeah, I mean, the working group last call obviously would be just informal because it's not our document, but
right.
But yeah, I agree. It's we something like a last call process would be good to do here.
Okay, thanks.
Mm-hmm.
Tim Winters, QA Cafe. Ted, I was concerned when I read this a little bit about flapping. RAs disappearing, going up and down. There isn't a whole lot of text about that. We should probably put some words about what we think is going to happen, because I'm worried that, you said, give users a warning, and maybe that is our out here, that we're not trying to fix it or do something bad that would cause constant thrashing, but we probably want to put some words about what's going to happen in that scenario.
There is actually some text in the document already that talks about this. Let me see if I can find it here. Yeah. Oops. The GitHub page will not help me.
All right, I'll go back. I mean, I'll go back and take another read at that, Ted, and see if I thought.
Yeah,
that's what jumped out at me when I read it.
Yeah, no, that's a really great observation, and I think we have the text that we need. Basically, I mean, the answer to your question, which I think is in the document, is, in principle, the infrastructure router advertisement is going to always win unless it's flaky, right? And if it's flaky, there's not anything we can do about it. If there are other stub routers, we have an algorithm. We basically do an election. So
Right.
So there shouldn't be flapping, because if two stub routers advertise, one of them is going to see the other's advertisement and say, oh, that one wins the election, I'll stop advertising. And the other one's going to see the first router's advertisement and say, oh, that one loses the election, I'll keep advertising. So I don't think we're going to get flapping, but I definitely, I'm sure you've got many, had many experiences with routers misbehaving.
Right.
So if you see anything we can fix, please tell me.
So typically where this comes up is when it's a wireless uplink. So it's like a mesh type setup, but it's doing it at layer 3, and the wireless multicast packets are disappearing. Is when this, it's not actually link flapping as much as it's packet loss, is when all of this goes south. And so that's, they look the same, right? Link flapping looks exactly like that. So that's just something, I'll go back and take a read at it with those glasses on and see if something pops out.
I wonder, I'm wondering if, I can't remember, I put the actual implementation that I've done of this. Oh yeah, here it is. Router unreachability detection, section 5.1.2.2.2. So basically the idea here is to use unicast to probe. So if we get an RA and then unexpectedly we don't get a new RA, we probe the router with a unicast. And so in principle, that keeps us a little honest. Yeah.
Okay. Yeah. I'll take another look at it. Thanks, Ted.
Great. Yeah. Masanobu.
Hello, I'm Masanobu from NEC Platforms. I just have a comment. Why don't we need a requirement section on the document? Because it's more easy to clarify the specific requirements. It's like 7084.
That's an interesting point. I hadn't really thought about that. I mean, I'd certainly, if you feel like sending text, I would certainly be happy to look at it. I'm also happy to just consider it, even if you don't send text, but I'd have to think about what that would look like. But yeah, I agree. That sounds like it's worth considering.
Yeah. Thank you so much. And one more thing. This document scope is also global reachability from the internet to the stub network also.
So that's a wish, it's not guaranteed, right? If you set up a stub router and you have DHCPv6 prefix delegation on your network, which Tim's going to talk about in a minute, then that would enable global reachability. And also, if you don't have DHCPv6 prefix delegation, you can still use NAT64 to reach out to the cloud, but you wouldn't be able to receive packets from the cloud other than through the NAT translator.
Okay, so if it's also included, maybe we should think about IPv6 firewall function. I think it's related to the UPnP function also.
Yeah, so
I have some
we did talk about that, but the problem is having a firewall on an automatic device is problematic, because our goal is to enable communication with the infrastructure network. So if we have some kind of automatic firewall in place that prevents communication with the infrastructure network, then we've failed. And so we've been assuming that the infrastructure network already has a firewall. And that would normally be the case. Like a typical CE router that follows RFC 7084 has a firewall. So that firewall is going to protect the stub router as well. This is not to say that there isn't potentially work to be done to improve the situation. Like, for example, you might want some kind of isolation between your IoT network and your main network. And I think that would be an interesting thing to pursue. I don't think it needs to be in the base document, though, because I think we still get functionality that we need in the base document. And so to me, that would be more of a value added than an absolute requirement.
Okay, I agree with that. Maybe future work, right?
Yeah.
if
Exactly.
possible. Yeah. So I will review this document. I'm interested. So I
Great.
will
Thanks.
comment
Thanks.
some comment on the list. Thank you so much.
Great. Yeah.
Remy.
Oh, Kieran, did you want to say something? I'm sorry, I didn't mean to preempt. I guess not. Remy, go ahead.
So hey, Remy and Nguyen Van. Actually, my name gets half cut by Miteko. So from Google, actually the Android part of Google. So I just wanted to react on the remarks about saying if we have some other potential implementation that could look at the draft. We've actually had some discussions of requests on implementing part of this in open source Android, the Android open source project. So I mean, I guess like bandwidth is a bit scarce at the time, so can't really promise. But I'm also interested basically in I guess looking at it, because if it lands in in our area, so we need to actually implement it at some point, then it's probably a good idea to have a good good look at the draft early. So and we've also done a lot of work on MDNS this work, so it's kind of unfortunate that we couldn't meet in person this time. But yeah, basically just saying we might be interested also from the Android side on that draft. So I'll try to have a good look at it too.
Great, that would be wonderful. It's really good to have somebody come along that I haven't talked to about it before and is interested.
Yeah.
Yeah, thanks a lot.
Any more questions?
Looks like-
Ted, I had one question about SRP. Is it mandatory for service discoverability?
Yeah, so that's a great question. When we were doing the HomeNet thing, there were some experiments done with MDNS bridging, and ultimately the conclusion is that just doesn't work. And so if you're going to have the ability to discover devices on the stub network from the infrastructure network, you need some way to do that. It doesn't necessarily have to be SRP. But the problem is, if it's not SRP, how do you get it onto the infrastructure? And so the nice thing about SRP is that it allows you to maintain a DNS zone. And that's done through, unicast communication with the devices that are advertising the service. And then if you want sort of permissionless advertising on the infrastructure network, you can do that with an advertising proxy. But that kind of falls apart if you're doing MDNS on both sides. I wouldn't say that it's impossible, but it's definitely uncharted territory. And so we haven't really tried to solve that problem, because what we really want to move in the direction of is actually doing less multicast DNS and more unicast DNS. So there's work going on in the DNSSD working group to move in that direction, and also in other standards bodies, other SDOs, to basically try to provide better unicast DNS automatic service registry infrastructure. And so right now, my focus has just been on getting the advertising working on the infrastructure in the sort of IoT use case, where SRP really makes sense because it's sort of a greenfield environment. Like we don't have existing Wi-Fi clients that don't know how to do SRP, so it's okay to use it in that case. For the sort of Wi-Fi to Wi-Fi stub network case, obviously, you can't assume that devices that are connected to the stub network with Wi-Fi know how to do SRP. And so in order to enable that use case, we would either have to just require that devices that are using that network actually implement SRP, which might not really be plausible, or come up with an MDNS solution that solves the problem better than just a bridge. But I think, again, that's probably future work, because I can imagine how to do the MDNS to MDNS bridge, but I'm a little skeptical that that's a good idea, honestly. So it's really just, to me, the question in my mind with reference to what you're asking is like, how long is it going to be before my, my Android phone or my Mac or whatever knows how to do SRP? And if that's like, in a year or two, and I'm not saying it is or isn't, I'm just saying if that does happen in the next couple of years, then it's probably better to just wait for that to happen than it is to try and come up with an all singing, all dancing, two-way advertising proxy.
All right. Thanks. No more questions for Ted, and we are moving on to next presentation.
Okay. This is a presentation I gave this week in V6 Ops. I updated it a little bit for this working group. And so if you've already seen it, I apologize. I do have some new things to add, though. Oh, it says V6 Ops. Sorry. Go ahead to the next slide. Thanks. Okay. So this is a draft I wrote to try to solve the problem of ISPs are assigning prefix lengths larger than 64 to a network. So they're doing the great work of 6177. They're not just, unless you're in a place where your service provider is just giving you /64, they exist. But there are a lot of ISPs who are giving out more than 64. The problem we're having today is that unless you're directly connected to that edge gateway from your service provider, you can't use all of those lovely addresses they're giving you. And that's because the typical IPv6 routers do not have a PD running on the LAN interface, very few. We looked at I think we have 35 different implementations or something we looked at, and I found 2 that actually had it, and you had to turn it on. It didn't come standard with the box. You had to do some configuration. So this draft is trying to solve that problem and take these large prefix pools that we're getting, whether it's a 56 or 60 or whatever it is, and go to links beyond, directly connected to the service router. So that's the problem we're trying to solve. One thing to note here is we're not trying to solve the problem of multi-provisioning with this draft. We're not trying to hurt it in any way or make it worse, but we're not trying to solve the problem of you have 2 exits from your network and how that would work. That's a different problem for somebody else to work on, or maybe later. Next slide. Okay, so a couple topology maps here. This is a pretty straightforward one. This is what happens today, as I say. This is a /56 from your service provider. He gets it on the LAN interface. He puts out a router advertisement. There's a PD request that comes from another 7084 router. So this would be something you'd get off the shelf, plug in, whatever it is, sends a PD uplink. It gets no answer, typically. It gets no prefixes available. In a lot of cases, actually, it just gets ignored by most home gateways. So the problem is that little smiley face should really be a frowny face. He does not have V6 on that router that's sitting below there, and that's not exactly what we want. It's no global V6. You could do funny things with ULAs and horrible, very hard things to configure, but that's not what we want to do. So what the draft suggests, go ahead to the next one. So yeah, oh, right. Let's talk about this. So one of the things, we have a couple of options going forward. For those familiar in this room, there's probably a couple of people with the HomeNet. The HomeNet suggested, and we spent a lot of time looking at hierarchical prefixes, and what that really means is the edge router gets that /56 or /whatever, and you come up with some sort of algorithm for figuring out how to split it up. And then you try to do the best. It's basically a tree distribution where you have to figure out how you're going to break it up. It gets pretty complex, right? All the documents that we wrote for HomeNet about this were pretty complex, and to be completely honest, scared everyone away. So this is another attempt at it going the other route. We talked about this in HomeNet, but decided that hierarchical, we were doing a lot of other stuff at the time, and we thought that was better. But here we are. None of that got deployed, so I think this is the middle ground here. It's a flat. What we're suggesting in this document is that there's a ISP edge, the CE router at the edge here says, hey, I've got these prefixes, and it's giving out multiple IAPDs outside of it. So it's a flat setup, and I'll talk more about that in future topologies. So this is the really simple one. This is very straightforward. This is a utopia for us if this is what happens. This one, the edge router gets a 56, and then, but in this case now it's got PD turned on very normal PD setup, as we say. It's gets request. It sends back a /64 from its big pool, and the guy on the bottom has a working v6 address. So this one's very straightforward. This is if you take a router and plug it into the one your service provider gives you or the one that you're using at your edge network. You plug in another router and it can talk to it. It could be a SNAC router. Obviously, in this case, it would work just fine. I put 7084 on this because more we'll talk about, as SNAC routers go further away from the edge, it becomes a problem. So we'll talk about that in a second. Okay, so this is the one I get the most questions about. I call this complex. It doesn't look that complex, but it definitely causes problems. So this topology here, you have two routers underneath your edge router, and they're both going to ask for IAPDs. In this case, they can ask for larger hints, but you're only going to give them a /64 at first, and that they all get 64s. They're handing it out. This one, regular PD rules here. You get a request on link, you can easily send back the DHCP message back to them saying, hey, here's your prefix. You can assign it to the LAN. All of this just works today. This is pretty well known, regular DHCP. Nothing fancy is happening in this topology. And the last one here, this is where the fancy stuff starts to happen. So in this case, what's happening here is you've got to get the PD on this bottom router here all the way up to the edge router. So what we've done to keep the flat hierarchy is we turn these middle routers into relay agents in DHCP parlance. So what we've done here is the SNAC router sends up a PD request, and then the 7084 router knows that it got a 64 on its WAN interface. So if it's getting PD from its LAN, it should pick up those PD messages and just relay them up. And eventually it hits the edge router, who will then give out a PD from his pool. So he's the only one giving out PDs basically in the home network in this model. It's flat, so he's got them all, and then he hands them out to individual networks. You can ask for multiple PDs. You would just ask for multiple options. That works just fine in 8415. So this works that way. The one catch is we are making these infrastructure, these middle routers do become relay agents. A lot of them do have it on there, but this is definitely a change. This is not normal behavior for them. So we're now asking kind of two things here. Dave, you want to go? You want to wait? Okay, that's fine. Okay, so right, this is what I was just talking about. So why this is important is, the requirement changes we're asking of home gateways, and this is in v6 ops because 7084 came from v6 ops. So that's where this draft is sitting right now. It's basically an update of 7084. We're going to ask them, hey, the simple case that we should get out of this, and we should do almost no matter what, is start having these guys turn on IAPD. Couple things here where we're going to say, hey, the server's got to be capable of processing relay messages. And also it's got to be able to give out a prefix length of 64. We don't want them trying to break up the PD anymore. And on the relay agent side, so this is in the case where it's one away from the main router. They should pass that up, the relay up. One thing here that I already ran into is talking through some people, they were relaying the IANA messages as well, which we didn't want. So that's something we added to the draft to stop people from relaying the IANA packets up the network. That's not what we want to have happen. That causes a whole different issue. The only other thing we put here is there's a relay agent draft that came out of DHCP, sorry, RFC, it's not a draft, that came out, and we talk a little bit about that with the installing routes, right? This only works is if you're doing PD snooping. You're learning the PD routes as you go along and you install them so that you know where your next hop is and where to send those packets. So I think that's all currently in the doc. I think that's everything. Yeah.
David Lamparter, can you go back to slide 7? Yeah, this one. I didn't quite catch how the 7084 router knows that it should do the relay as opposed to terminate PD, basically, because it's talking directly to an ISP.
Yep, if it gets a /64, if the only thing it's getting is a 64 length PD on the WAN interface, it just relays it up.
Okay, thank you.
Yep. Esco?
Let's go.
Yeah. I had a question. So I understand that the /64 delegation is a requirement here, even if let's say the request is for another length, like a /62 or something like that. Could you just briefly explain maybe why that's needed?
So, right, the reason I do it that way is so you can easily tell who has all of the prefixes. If you allow hints and stuff, then you have to figure out how to break them up, and we're back to the hierarchical model, and that's a nasty business. So it's basically cheating here and just giving out 64s so that you don't have to figure out all of that math. Was the general idea.
Yeah. Okay, and it's even if the requester is not even planning on breaking them up, just for whatever reason, request a /60, for example.
Yeah, even as you ask this, I think I'm going to put a rec in there to ignore the hint, basically, and say, hey, you shouldn't be paying attention to the hint if you're doing this, because it's not going to do you any good. Okay,
but this is stand for typical home situations, right? That this works, but maybe not in general. Yeah. Okay. Yeah,
this is really for the person giving it out. You can ask for it because one thing that comes up a lot in this picture is you don't know if you're a 7084 router, whether you're actually at the ISP edge or you're in the middle of the house. So you're still going to want to ask for the hint, but on the reception side, obviously the thing I have labeled here, the V6 CE router should ignore when people are asking them for /56s, right? On his LAN interface, he's not going to be giving those out. He's only going to give out a 64.
Yeah, just one quick question. So the two routers are actually both 7084 routers, right? Also the CE router.
Yeah, Barbara's not here to make fun of me. She gets mad when I do this. So the deal here is, it's a 7084 router in the middle, which is supposed to be a customer edge router by definition. We don't have any better definition for those middle routers, right? I mean, it's a home gateway, it's a wireless AP, these are all 7084 things. I know it's not actually at the edge. I get it, but I don't think it makes sense to try to give it a whole different name. I think we tried that. I think we wrote a draft spear or something about that many moons ago trying to solve this problem. And I think we can get away with this, but yeah, that's why I labeled them differently, just to show one is actually at the edge and the other one's sitting in the house.
Okay, yeah, that's clear. Thanks.
So everything without any head. About your referring to V6Ops, that's a V6Ops draft, right? It needs to be discussed there. But if you post a new version, I suggest to put SNAC in CC, because V6Ops is a pretty noisy, in my feeling, mailing list. So I don't want to read all those emails there.
Okay, I will make sure to do that. Thanks, Eric.
Thank you.
Good. It's good feedback.
It's a good suggestion.
Eric Klein. If I recall correctly, which I may not, from HomeNet, some of the complexity was when people unplug routers and plug them in differently, and it was supposed to magically reconfigure itself such that there wasn't a renumbering event. In this scenario, I assume there's renumbering?
Yeah, I mean, so yeah, the original HomeNet thing, we had two problems originally. One was trying to figure out what up and down was. If you remember, we had the whole, you could plug in your WAN interface. You didn't have to define your WAN interface was one of the ideas that was at a HomeNet.
Yeah.
And so some of the problems came from that because you were trying to figure out where up was and where down was, right? And then we broke it up in different ways. In this case, renumbering hypothetically should just work like a regular DHCP prefix renumbering event, right? Because again, we're just building this on top of DHCP. So what will happen is the CE router here will get a new prefix and then it would eventually propagate down. One upside here that often we say we can't use DHCP v6 reconfigure, but every 7084 router has that built in. So you could actually, in this case, use reconfigure all the way down and actually renumber the entire network.
If the DHCP6 PD client uses the same identifier and uses the same /64 in the hint, you can ignore the hint if it's not 64.
Yep.
Perhaps.
Yes.
You were talking about adding a recommendation.
Yep.
would that be possible to just have it reallocated and have things snoop along the way and observe that the routing had been updated?
Yes.
And then because the router would know that there's maybe a link down, a let down of event, or it would know that the upstream router had.
Yeah, I
failed a
mean,
nut check.
right. And all of this, if something happens, it should do a rebind and go and ask, right? In DHCP terms, it should do a DHCP rebind and say, hey, what's my PD? Is this still right? And it can answer it and say, no, I've learned all new stuff. Or
So it might actually just work.
yeah, it'll just work.
Yeah.
In theory.
That sounds good. For large values of work.
Can I hop in with an answer to that? If you move the SNAC router to a different upstream link, it's going to fix the state on the new path, but the old path may have broken state.
Right.
Yeah, that's true.
Yeah. Good point. Ted, fire away.
And if that's all right, Ted Lemon, the broken state situation is probably not quite as bad as it seems. And one way to address it, so the way that would work is essentially you've got the DHCP server knows where to send the packets, right? And so if the router gets plugged into a different place in the topology, the path to the router is going to get fixed, and the path to the router on the old path to the router is going to be somewhat irrelevant, but you can still send reconfigures if you want to clear it up, and it might be worth thinking about how to do that. But additionally, well, I'd say actually sending reconfigures is probably the best way to address it. You'd essentially just send a reconfigure down the same path that the original packet, the original PD was delegated on, and that would just clear out. You'd have to define some new behavior probably, but that could be used to clear out the old path, and then you send the actual response down the other path.
Yeah, it's the relay agents learning the routes is where this is going to be a little problematic.
That's what I mean. You would have to basically, so when you got the original prefix delegation request, that came through a series of relay agents. So the DHCP server in principle knows which relay agents it came through. So if that path remains, except for the very end of it, or even if some part of that path remains, then if you send some kind of DHCP message encapsulated through it with the same router option, basically that clears the route instead of adding the route, then that should clear out the old state. I mean, to some extent, we shouldn't even really be talking about this because we should just solve this problem with a routing protocol. But to the extent that we want to do something to address sort of the easy static use case, I think you could actually do that.
Yeah, I'll have to think about that. There might be some mechanism we can use. I mean, there's least query. There's some other things we could play with here.
Yeah.
Least query might be the answer to this problem as well. Just having the relays talk to the server occasionally and say, hey, is this guy still here? Might be the best
My only
way
concern
to
about that is like, how much complexity do we want to add to solve this when we should really just use a routing protocol?
Yeah. You just say just use a routing protocol.
It's easy. Everybody does it.
No. Yeah, I mean, that's what we're trying to avoid here for sure, right? I don't, talking to home gateway vendors, I think there is a very, 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 very low chance of getting a routing protocol on those boxes. So we should keep that in mind.
Marky,
yeah, I was just going to say we actually had two documents, right? One is the simple and one is so.
Yeah, we could talk about the complicated one when we're there.
Yeah.
Thank you.
Right. What I would say to the whole routing protocol thing is, like, yes, it's true that routing protocols are complicated and routing vendors are probably going to feel a little bit allergic to them, but it never hurts to ask, right? So I would actually be inclined to say something about, so a whole bunch of work was done in the Babel working group to come up with a routing protocol that was sort of automatic and easy and self-configuring. And, I don't think we're in a position to require that people implement that, but we could certainly at least say, if you're going to implement. End up for us just responding to the previous.
Ted, could you repeat a bit? We lost you for a No, we lost your voice for a bit, so can you repeat last couple of sentences?
With issues with ISPs and various different behaviors that ISPs exhibit when given various kinds of DHCP PD requests. Like, if you ask for a /60, but last time you were given a /56 or something like that.
Yes.
And so I don't know if you've got any text in the document to address that yet, but if you don't, it might be worth collaborating. I know I could introduce you to some people. You may already have met them.
Yeah, well, so the thing about this is in this draft, we can talk about that actually. I don't have a whole lot of text about the WAN interface. I just kind of copied 7084 and did that deal. So I'm happy to put some text in there if we think there's, funny things going on that network. So yeah, Ted, I would welcome that.
Great. Yeah, I think part of that really just needs to be another document that says if you're an ISP, here's what you should do. But to the extent that we can mitigate it by putting something in 7084 plus this, I think it's worth doing.
Okay. Yeah, I think we could definitely give them, I think we should talk about it from the perspective of this is how service providers have done this for sure, right? These are some common issues that service providers. We could talk about that from the 7084 routers perspective for sure.
Cool.
Lorenzo?
Yeah, Lorenzo Colletti. I wonder, I don't know if you've already talked about this, but what happens if the ISP gets a delegate, like a relayed request before it gets the one from the main CE router? Because like the IPv6 CE router is also a 7084 router, right? So,
yes.
So if the one in the middle sends a request before the one at the top has started up their client, then you have like a stably broken situation, right?
Well, so what's going to happen? So right, if the CE router I have labeled here, right? If it doesn't have an address, right, the guy below it's just going to get no answer, no. Even if he's up, let's say he's up, right? He's going to say no prefixes available until the ISP gives him one, right?
No, because he's a relay, right?
Well, he's not a relay yet because he doesn't have a PD. You only become a relay when you get the /64 on your WAN.
I see. Okay.
That's how I get around that problem.
So, okay, you only become a relay once your delegation has succeeded. Okay, so yeah, then you do have a fix for this race condition.
Yes.
Okay,
yeah. I worked around that. I cheated.
And that's must, right?
Yeah. It'll end badly otherwise. Okay. I think that's it.
Any other questions? Good. So that's what we had, these two presentations for today. And I think we have a lot of work cut out for us. Reviewing this document, Ted's document, and a couple of other things. Yeah. Yeah. So thank you guys. You guys have 10 minutes back. Thanks to online participants.
Thanks, Karen. Thanks, Mark. See you next time.
See you in SF. Can leave the room.